All right, thanks for coming today. Those in this breakout session, my name is Travis Oliphant. I'm accompanied here by Darhas Patina, Andrew James. We're from Open Teams. We are here to talk about open source AI tooling and building the next generation of AI infrastructure, and to hopefully start some conversations, give you an idea of what we're up to, some of the people we're collaborating with, and who we'd like to be collaborating with, and what we'd like to be doing in the next year. Go ahead, let's see what we've got. So I know that we're all here at PyTorch, and there's a ton of stuff, new technology flowing around, lots of ideas flowing. And a lot of times it's easy to forget how we got here. We got here on the shoulders of a lot of people who built a lot of software in the open for a long, long time. I'm getting older, and I'm kind of one of those people that's been in the industry for a while, trying to help coordinate software at the roots. I started a project called Scipy way back in the day, started and wrote a project called Numpy, and then later a compiler called Numba, which is one of the very first compilers that enabled you to write Python syntax and get really fast performance even on GPUs. Now everybody's doing that these days, which is super cool, but there's things, how do we do it even better, and how do we do that in the open, in a more open source way? So AI depends on open source, open science, open infrastructure. So there's more to remember. Move on, let's take the next slide. So we are Open Teams. We actually help we help build and maintain open source. Some of these you know, some of those you may not know. Most know Numpy, Scipy, PyTorch, of course. Numba, if you do know. CondaForge, a massive community of people making binaries available for everybody, making it easy to install. Jupyter Lab. These are things people at our team at Open Teams were part of making happen. We support JAX and PyTorch. Data APIs. Who's heard of data APIs? Probably not many. Oh, a few people have. Okay, it's selection pressure. You're here because of that. Data APIs was an initiative to try to help unify all the arrays out there, all the data frames out there. We made a lot of progress with arrays, still working on the data frames, but Array APIs helps build an array API that multiple downstream libraries can use instead of all depending on Numpy, or all depending on PyTorch, or all depending on any new array library. So Data API is an important project that we initiated about 5 years ago and continue to support. And then many, many more. At Open Teams, we hire people to work on these systems, and we also partner with other companies like Quantsite and others who hire people to work on these open source projects. We really, really support the communities where we come from. Our history, so we've done this for a long time. We being the collective and we've got 3 people on the stage here, and we've got 50 people at Open Teams who are all part of this. And then we have a sister company, Quantsite, where there's another 30 people who have been doing this a long time. And then I have friends previously, and you can see the projects we've been involved with for at least 25 years now at the roots, and we're still going strong. We think there's even more that can be done with AI making code generation possible, and AI making community conversations happen more quickly. That's what I'm hoping, is AI can help us communicate with each other. So there's a lot to understand. If you're like me, you go to a talk and you barely understand, maybe 25% of what they're talking about, and there's a lot there, and it's hard, but you can use AI to help you actually and get some backstory before and ask better questions about what you're learning about, because there's so much we can collaborate on. So we've been doing this for a while. Lately, many people know about Anaconda. Anaconda is the first company I created along with my co-founder Peter Wang, and it was really trying to bring data science to the masses. We started Quantsite in 2018. That's where Darhas and Andrew joined me. And then it became Open Teams, and we merged with Open Teams just this year. Quantsite and Open Teams merged forces while keeping Quantsite independent, as Quantsite Labs independent as a public benefit corporation. But we also have venture funds and an incubator. So if you're an entrepreneur looking for a way to build a new billion-dollar company or even a $100 million company, that's okay, on open source, come talk. We'd love to help people create business from open source. Numpy to NumFocus to PyTorch, and then Zypher. There might be a Zypher fan in the room. It brought me to Silicon Valley. There's some great people building some open source models. I know that's one of the questions today. AI is everywhere. What's the status of the open source models? We're not going to answer that today, but we are committed and excited about the potential for open source AI models to make AI everywhere possible. Let's move on. So at Open Teams, you can kind of think the blue pieces. We have a sandwich approach. At Open Teams, we support the lowest levels. We work with engineers at Meta, we work with engineers at Google and NVIDIA, other places to build better infrastructure, to make improvements to PyTorch, to make improvements to JAX, to make improvements to TensorFlow, to make the software work better, to enable hardware. And then we also build enterprise AI solutions. We help people build, let's call them automatic workflows, using those tools, but it's much more solution-centric. In order to accomplish that, we have a big middle of community participants, open source software, commercial partners, community partners. We can't do it all together, all ourselves, but we try to make it easy. We put the easy button in sovereign private AI. And Nubari helps us do that. Nubari undergirds all this. Now, it's been a platform for machine learning and data science, and we're talking today about how it's evolving. We're evolving it to create a platform for AI deployment, for chat MCP tools, and we'll talk about that. In fact, I'm going to have Darhas talk about it in just a second. Darhas?
Hey, so my name's Darhas Patina, and I'm the CTO at OpenTeams. And I was in government research labs till about 7 years ago and moved to Quantsite, now OpenTeams. And when I moved to the private sector, so when I was in the government, I had access to nice big supercomputers. And then I moved to the private sector, and oh my goodness, it is so annoying to install AI, data science, numerical tools in the cloud. And so about 5 years ago, we got fed up and we started building a solution to install all the stuff you need so you can actually get on with your work. And that was the first version of Nubari. And over the last several years, we've been building this open source framework that is deployed at quite a few places in government agencies and banks and private sector and other places. And essentially it is, if you decided, I want to build my own data science, MLOps, AI platform in the cloud, and you look at Nubari's architecture, you'd probably come up with something very similar. You'd use Jupyter Hub, you'd use Dask and Ray, you'd use a set of tools. And what Nubari is just those tools put together in an opinionated way as an open source, open architecture thing that we can install on any cloud in about 30 minutes and get on with our work. And so that's where Nubari is right now, I guess, as of a few months ago. And it's basically focused at, it's a Jupyter IDE-based environment that's focused at a data scientist, data engineer, research scientist type person. We're taking that framework, and as we looked at what we've built, we're separating it out into a modular AI infrastructure so we can deploy the base infrastructure that lets you do have a model inference server, have code generation workflows, have chat-based. And so again, Nubari old was kind of focused on the data scientist, engineer, coder. Now we're saying this is the same infrastructure that's going to power your agentic workflows. This is the same infrastructure would power deploy dashboards or stuff in an organization. And the whole point is we want to be we want this to be a community-built open source system that an organization or entity can install and have everything they need to do AI workflows and not be locked into any vendors or anything else. And so this is where we're going with Nubari. And I think this, yeah. And part of this, I'm going to talk about one piece, because when we built the original Nubari system, we found a big problem with software environment management. Who has had problems installing Python stuff? Okay, if you haven't put your hand up, you will have problems installing Python stuff. I guarantee you. If you look at the Scipy user mailing list and Google my name, you will find a question in the Scipy user mailing list in 2008 or 2009 about me asking how to install Scipy from SVN on Red Hat. And so this has been a problem for a long time. The current generation of tooling, there's one set of tools being built for developers. You got UV, you got Pixie, you got all that kind of stuff. On the other side, you have tooling being built for DevOps people. There's a big gap in the middle of tooling for organizations that need to manage AI environments and lifecycle management. And we have, our existing product has a prototype of some of those tools, and we're building the next generation, which actually will solve some core problems that the ecosystem hasn't solved. And if you want to talk more about that, come talk to me afterwards. I will talk your ear off.
Great. Another problem. So we're talking about kind of two of the main problems that Nabari, the next generation, solves in order to get to a space where you can install AI workflows for yourself on a platform of your choice, hardware of your choice, ecosystem of your choice. It's a big lift. It is. We know that. That's why we're raising money. That's why we're closing around. That's why we're engaging a large community of people to help us. Because we believe that the future is sovereign AI, sovereign data, AI that people own. Solutions that are distributed. And we're partnering with anybody who wants to help us do that. And so 2 problems we are technically solving. One is the environment management problem, to help people have reproducible environments quickly, 1,000 of them. Individually, you need to have access, the ability to redeploy, especially if it's going to come onto your hardware. If you're just calling APIs in the cloud, not so big of a problem. But if you want to deploy onto hardware you control, big problem. You need to do this quickly and easily. So we're looking at that, and we're partnering with the right people to do that. And then on the compiler side, and I'll have Andrew James here, who leads the PyTorch team, talk about this. I wrote Numba 13 years ago, the very first version, fortunately got replaced by people better than me. But the whole goal was to build something that let you take high-level expressions, kernels, in fact, and embed them in Numpy. Embed them so they could be optimized. Now, since that time, this, it's sort of how do you help Numpy users write things faster? And we have Numba, we have Python. They're all kind of cousins of each other, doing similar things. You do some static type annotations. You do some compilation. Maybe it's just in time. Maybe it's ahead of time. Numba had 2 things that it failed to do, right? One thing it failed to do was create ahead of time compilation. And so it was actually sad that we could not use Numba in Scipy, right? That for me is like, I was a creator of Scipy and I was a creator of Numba. How in the world is Numba not able to build things that Scipy could depend on? In fact, one of my demos of Numba was replacing the special function out of the CFEs library with Numba code that worked 15 years ago, or 12 years ago. But still, as a person, you can't write that. And because we didn't do ahead-of-time compilation for Numba. Now, Numba team, there's reasons for that, and they're making improvements. But we have the static compiler that wasn't able to be used by JAX and JAXPer, wasn't able to be used by PyTorch, wasn't able to be used by all the people that could use it. Okay, how do we create a community standard that makes that happen? The other failure of Numba was. Remind me, oh, thank you, yeah. The other failure was nobody knew exactly what subset of Python Numba was compiling. What exactly is it compiling? Like even today, if you go, oh, does this work if I put a JIT and if I ask Numba to compile it, will it? Good question. I mean, it punts by just calling the Python runtime, and that's great for usability, actually really awesome for usability, but in terms of standardization, really difficult. So it's hard to know what is the subset of Python that Numba is actually compiling. So since that time, there's many others. There's hundreds of others. And the same question I'd ask them, what subset of Python are you compiling? There is none. There's no specification for this. So these are 2 things that we think need to be organized in the community that actually would help the problem of taking high-level people, knowing the kernel they're writing, knowing what they're trying to accomplish, build something that can then be deployed on any hardware, not only today, but in the future. So Andrew's going to talk a little about how that dovetails what's happening now.
Thanks, Travis. So I wanted to take a second to talk a little bit about, kind of the modern story that's developing that really, I see a lot of parallels between the Python Numba development and the NumPy community. And now within the PyTorch community, post-Torch compile, we have, Triton was a massive development and accelerator sort of lifting the interface for that low-level programming to meet the developer where they're working. And now we have Helion emerging to lift it one layer higher, right? Remove one level of detail that you need to think about, automate part of that workflow. And so we're really on the verge of, there being a need for something like the data APIs effort in the compiler space, right? Where now we have high enough level interfaces, high enough level abstractions that we can actually build useful compiler backends that sort of standardize on an interface and open up this, sort of hardware agnostic ecosystem for accelerated kernel development. And this is going to be really critical to, our mission as we hope to bring Nabari as a, platform for delivering AI AI solutions to our customers, right? Nabari, the early Nabari story, we figured out a lot of, becoming cloud agnostic. Now we have to make sure that our entire stack is hardware agnostic as well, which is not going to be an insignificant lift, and we're not going to be doing this alone, right? We are already collaborating with the Meta team on Torch Compile and have been for many years, essentially since the project started. I would not say that it'll be too long before we're also working on Helion. And if Helion is that correct level of abstraction, then we're going to be working to integrate it into every piece and every component that it's needed in. If Helion's not the correct abstraction, then we're going to be working to figure out what it is. And we're going to be working to bring together hardware vendors and compiler developers to innovate in the space. And that's essentially, my take.
Perfect. Thank you. Thank you. We only have a little bit of time. I talk about those two areas of innovation because if you're interested in this, we're going to be hiring. We're going to be investing in these two areas, making environments work seamlessly and making compilers work seamlessly over the next year. So if you're interested, come talk with us. Come work with us. Now, even if you don't want to work with us directly and you want to partner with us, let's do that too, because we can't do this alone. And I described our business model actually as providing solutions with an infrastructure support using community partners. So both partners, communities, commercial partners, we are open for business. We're open to connect, open to lots of people out there have great products and services, and we'd love to integrate your services with our customers as well. Here's just a couple, and I only have a few I'm going to go over. These are people that I could get slides from. I hope that there's hundreds of people here that we could partner with. One is a group I've worked with a long time called Bodo. They recently open sourced their compiler for pandas. They took Numba and then made it possible to compile pandas with it, and as well added MPI integration so you can compile to a distributed machine quickly. And now it's an amazing engine. They've actually got performance results that show just with pandas code, you can have optimized database code. It's like faster than a SQL database just to write pandas, compile it with Bodo. It's actually amazing. They have some amazing results. So this engine is available. They're demoing in our booth. Come talk to the folks at Bodo. But they're an important partner as we think about standardizing compilers and making it possible to write high-level code with fast implementation and fast coding. Another partner we're working with is a NAS. Now, a lot of people, you hear about ontologies with respect to AI. I see ontologies as really getting your data agreement. Like a big problem most industries have is they go, great, I want to do AI. Okay, cool. Where's your data? Oh, well, how do you think about your data? I think about my data this way. Oh, another group in your company thinks about data a different way. Their schemas are totally different. A lot of ontologies are about really unifying people's perception of what it means, what data means in your organization. And if your AI workflow is going to be automated, it's really important that you have some agreement about what data means in your organization. So the semantics all of a sudden become interesting. And there's actually an interesting another product from Bodo called Pydo that actually creates a semantic language for data. It's a DSL for Python. It's definitely worth mentioning. Take a look at it. It's just recently come out, but they've got examples showing it absolutely reduces hallucinations significantly if you actually have code generated, you're generating a high-level DSL. This is what Nabari enables. Nabari enables you to use libraries like Pydo, use libraries like Bodo immediately, and add 1,000 more. And you can still have a common infrastructure and have a workflow that you use today. NAS again. Actually, I want to highlight Wheel Next. A friend of mine, John, is here. Andy's here in the audience. This is an initiative. We support the community initiatives that are trying to actually solve the problem of how do we distribute Python. Wheel Next doesn't solve all the problems, but it absolutely solves the problem of distributing variants, distributing the problem. I have two different kinds of PyTorch, and I need to have a single index. I don't want to put them in two different indexes. I want to have them in a single place so I can simplify my deployment. We partner with Wheel Next. We're really happy that they're doing their work, and we're excited about the progress the community is making towards making distribution easier. And there's a lot of folks who are participating in that, including people that we care about deeply. Jaros, you want to talk about, well, I'll actually just finish here and then we can take questions. This is basically just saying we are Nabari at Open Teams. We're about the community. We started the community. We pivoted to push enterprise solutions, enterprise open source solutions to be enterprise AI solutions. That's the pivot we did last year. And this year we're taking Nabari. When we merged with Quansight, where Nabari came from, OpenTeams is now taking Nabari and investing in the infrastructure, both on the compiler side, on the environment side, so that we can bring enterprise solutions to everybody. So if you're interested in partnering, you're interested in actually taking an AI solution and making it work in your organization today, come and get in touch with us. Talk to us. If you're interested in working with us, love to get your resume, love to get your conversation, give your LinkedIn profile. We are very eager to continue to grow, and we're excited by the future that's ahead of us. All right, I think we have just a few minutes for questions if people want to ask them. Andy, do you have a question? Or you're walking out? I see, no, it's fine. Oh, great question. So the question is, you're doing compilers, what's wrong with Triton, what's wrong with MLIR? Andy, do you want to take a crack at this?
Yeah, I mean, the analogy to data APIs is just that, an analogy, right? Like what actually is that standardization layer? It may very well be a high level DSL with its IR, it's like high level IR. It might be a first level MLIR dialect, right? That is then connected to Triton MLIR or whatever the names are attached to other hardware vendor stacks. Like, I'm not saying that this will necessarily be an API layer. I'm saying that this will be a community effort to standardize around something that promotes interoperability.
Yeah. So if something wins, we'll amplify it. Right, I would say. Right now, we're looking at that hard and would love the input of this community. I would say when I first started thinking about this last year at this conference, talking to people about ExecuTorch, the problem of taking a torch model and running it on a drone, running it on an edge device, and it was difficult. And basically they have a really good, a lot of work done, but essentially A to D. They go, here's my torch model, here's this binary output. And I thought, really, we gotta think about this in a couple of layers, a couple of stops where communities can develop around it. There's low-level IR, LLVM IR, and there's MLIR. MLIR is a great ecosystem. And I really support that ecosystem. Love to see it develop further. I think there needs to be one level above MLIR that's a little closer to the Python runtime, where we're starting to see DSLs also show up. That's where Triton lives. That's where Jaxper lives. That's where Numba lives. That's where Cython lives. I think there's an opportunity to standardize there and create more cohesion and more cooperation, so interoperability can occur. And that's what we're really after. How do we enable interoperability in this huge ecosystem so that more people we can go farther together than individually alone trying to create these silos? So that's the answer. I don't know if that helps, but good question.
My question is, how do you prioritize what tasks from the open source community you want to focus on and build, and how do you know that that project has been successful?
So the question is twofold. How do we prioritize the tasks a particular open source community works on? And then how do we know if the project's successful? You want to take a shot at one of those, Darhas?
Oh gosh, how do you prioritize? Okay, so if we looked at some of the things we did in Nabari previously, it's like, okay, we need a workflow tool. People want to run workflows. There's Prefect, there's Daxter, there's Airflow, there's whatever. A lot of them are open source, a lot of them are open core. Some of the open core models hide key features in their proprietary things. So the one level is just licenses and sustainable communities, I guess. There's another level which is, does it actually solve the problems you're trying to solve? And to some of the things, there's not one answer. Like for example, if you want to use Daxter or something else, to some extent, it's a preference. And so we're a little agnostic there in terms of which ones are a winner. There are other places like in the data APIs and this other story where we need, like the data APIs is actually a good example because 3 or 4 years ago, we worked heavily on the data frame API and the array API. Thankless work. Everyone said it wasn't needed. Travis went around getting funding from places. Now, if you want to use Altair from the visualization library from Polars, it's only possible because the data frame API exists. That's how it's happening. The most recent version of Scipy lets you dispatch to GPU because of the array API. And so some of it is also looking at what we want to invest in is the strategic open source that allows more of us to be successful with open source.
I'll make one comment. I think it's really important to solve a problem you have. Prioritize things based on things you know about. Especially in the AI space, what I've noticed is a lot of open source is doing an intellectual land grab about problems they think might exist. And that creates a lot of headache, actually. It creates a lot of extra cruft because the you ain't gonna need it principle is really true. And I understand that because I was a young person once too trying to invest in open source. But where the value comes is when people solve a problem they have and then they share it. And when that happens, amazing things result. So that's just solve a problem you have and understand.
I'll say that the way that you qualify success is important, right? Like I can stand up here and I can say that Triton, for example, failed to lift the user interface to the level I want it to, right? Is Triton a successful project? Absolutely, right? Did it fail? No. That was not the problem that that team was trying to solve. That's not the problem that that team at OpenAI continues to try to solve. And so it's important to build on what we have, right? Build on the success. So that team is solving the problem that they want to. I have a slightly different problem, and I'm going to take some of the wins that they had, and I'm going to try to add my own, right?
All right, thank you.
Thanks, everyone.